Today we have David Rice with us from Weber Basin Water Conservancy District, and he's the conservation coordinator there. And he is willing to talk to you all about drip. So I'm really excited for this introduction. Hope you guys enjoy it. There is a Q&A box at the very bottom of the screen. Feel free to ask questions if you guys want to use that Q&A box versus the chat box. It helps me keep track of questions, and we will get to those towards the end of the webinar. So with that, I will just go ahead and turn it over to David.
Thank you, Candace. You can hear me?
Yeah, sounds great.
Okay, so I think what you're seeing now is just the main front slide, the Drip Irrigation 101. I'll be switching over to talk and show you some things here in just a minute after I go through some slides. And just to maybe get started, a little introduction. I am not a sprinkler contractor, so most of what I'll be talking about today, I've just learned from contractors, from irrigation shows, from green conferences, from my own experience managing learning gardens and different things. My own experience, in my own yard. So I've used almost all of these products that we'll talk about today. I've got some background and experience with them. Trial and error is mostly how I've learned, but I'm happy to be able to present this today and hope that you'll gain some knowledge and a little bit of understanding about drip and how you can be very, very successful using drip irrigation. If it's set up correctly, if you know a bit about what you're doing, you can succeed, you can save water, and have whatever you are growing thrive in the landscape or in agriculture or whatever it is. So with that, let's just get going. Oh no, now my slides are stuck here. Give me a second. There we go. So let's start with drip irrigation advantages. This is basically the overview of why. Why would you even consider using drip when there's a lot of different irrigation methods out there, primarily spray irrigation in a landscape setting. And I don't know all of your backgrounds or what you're mostly interested in. However, with us at our water district, outdoor landscaping is a big deal, and that's where a lot of the water conservation efforts are focused because there's so much potential to save outside. So drip irrigation fits very nicely into that narrative of how do we save water, how do we keep landscapes, gardens, and everything else thriving. And this is one of the advantages of drip irrigation is you're delivering water where you need it without a lot of waste. You can control volume, you can control time, you're delivering this water. So, because of that control you have, it's benefit on any soil type. It works with sand, it works with clay, because you're managing the flow. You don't have runoff. You can run it as long as you need to soak up the soil profile. You have less maintenance because of less weed growth. Sorry, I jumped ahead a bit. Due to less weed growth, because you're not watering everywhere, you're only directing water to where you need it. And you can water any time of day or night. When there's areas or spray restrictions or different things in effect, drip irrigation works very effectively because you can essentially use it any time of day or night. You don't have the blockage of spray when your plant material grows. You don't have, then putting 3 or 4 foot risers on there just to try to get above everything. And in most cases, it's very easy to assemble. There's no glued parts. Sometimes there's clamps, depending on what you're doing. But most of the time, you can put it together and use it immediately. And any type of plant combinations, trees and shrubs, vegetables, raised beds, perennial beds, this is applicable in any situation. So really important, as I mentioned, I'm going to go through some slides. I'll show you some things in the slides, and then I intend to switch over to video and then have some pieces kind of show you the real physical pieces and kind of go from there and then address questions. So we'll start with the setup. One of the really important things that people may misunderstand or kind of miss altogether with drip irrigation is you still have to consider flow rates and overall installation and design. So the flow rate, drip versus spray, is very important. And we talk to lots and lots of people. I take phone calls every day. People just don't understand volume very well when it comes to outdoor irrigation. And so we have to help them understand the difference in flow rates when you go from spray to drip. And spray in general, people just don't understand the high volume. So it depends on pipe size. And there's a little chart that I've placed on this presentation. Now, if you look kind of in that yellow zone on that chart, those are the flow rates in gallon per minute and gallon per hour based on the pipe size, which is on the left side of that chart. So we'll just use 3/4 inch pipe for an example in this slide for drip irrigation. So spray head application, you're going to be talking about gallon per minute type applications. You know, spray heads can apply anywhere from 1 to sometimes even 5 gallons per minute on the really, really large commercial type heads. You can apply a lot of water very quickly for one sprinkler head. And so you get a zone of 5 or 6 heads. And you can be putting out, that's why on a 3/4 inch pipe, notice it says 23 gallons per minute. Well, you can't exceed the flow. That's as much water as will go through the pipe at a given pressure and so forth. And you can't really exceed that. So if you've got too many heads or too many outlets for that, things are not going to operate correctly. But in drip, notice with drip, now you're going 1,410, so about 1,400 gallons per hour, which means if you're using 1 gallon per hour emitters, you could have 1,400 emitters on that one zone of irrigation. And for residential application, I don't know anybody that would have 1,400 emitters in one zone of application. It's just really not practical in a residential setting. So essentially, you can put as many emitters as you need in one zone and not exceed the flow rates. So that's one really important thing. And this little chart's kind of handy in showing people the different flow rates for spray versus drip type application. Now here I'm going to switch over to a little YouTube video. So determining flow rate. Some people have a really hard time with this. Now in our area, we actually have pressurized irrigation water. It's not treated and it's separate. So to determine flow rate, it's a little different maybe than connecting from your house. Notice these pictures here. You got a bucket coming off of a hose spigot. Just quick, I'm just going to exit this here quick and switch sharing to a little video that I want to have you watch. And this will just take a minute. So let me just go back here and start over. Okay, so this is just a quick little video I found that will help understand how to calculate a flow rate before you get started when you're setting something up from water that comes directly out of your house, out of a faucet or something. Now, if it's coming out of your house, whether it comes out of your hose spigot or it's tied into your sprinkler valves, that flow rate's probably the same. So let's just watch this quick. There's no sound yet. It's coming here.
Determining your home's flow is one of the first steps in starting your drip irrigation system. To determine your flow, you'll need a 5-gallon bucket and a stopwatch or wristwatch. Place your bucket under the faucet and turn the water to full and immediately start your timing device. The flow is determined by the rate of how fast your water fills the bucket. Not to be confused with your home's water pressure, flow is measured in gallons per hour and factors into how much water your drip system can use at one time. Simply, the higher your rate of flow, the more your entire drip system can handle. Now that you have your time, divide the number of gallons by the number of seconds it took to fill the bucket, and then multiply that by 3,600. Or simply use the flow calculator provided to you by dripworks.com. This will give you your home's gallon per hour rate, or your flow. You are now ready to take the next step in your drip irrigation system. If you have any further questions about our products or installing your drip system,
so let me go back to my slides here. Oh. All right, so the bucket method to determine flow, it's pretty simple. That went really quick through the calculation, but you're basically using a timer, you're filling the bucket, and then there's a quick formula for calculating how much flow you're actually having per minute. So, and we can address that if there's some questions about that at the end. We'll just kind of move on from here, but we'll talk about that a little bit more if we need to. So once you know the flow, you're going to know the capacity of emitters you can put on and everything else. And that's going to be useful in a minute. The next step is you're going to be needing to set up from the source a drip zone manifold or valve setup. Now, I've got another slide in a minute that'll show you if you're not doing this only for one zone, you can actually connect this from a hose spigot and set it up that way. But most people in a sprinkler system will set it up using a valve manifold assembly. And anyway, these are a few pictures that kind of show a valve manifold assembly, where you've got your valves and then a pressure regulator and a filter. And I'll talk about each of those so separately. The images here on this screen are basically to show you how that valve manifold is typically set up inside an irrigation box with some of the different assemblies. Notice the picture to the bottom right. There's some funky, looks like melting of pipes to make all that fit together. I don't know that I'd ever recommend doing that, but I thought the picture was interesting. So here's a couple pictures of a standard valve and then a valve with a regulator and a filter attached. And as we get to the end, like I said, I've got some pictures. I'll kind of point out some things and open them up and let you look from the camera perspective of what that looks like inside those little filters. Very important on the regulation, there's a pressure regulator. So if you know the flow is a certain gallon per minute, if you've actually got a flow of 23 gallons per minute, and that's a little bit higher pressure, most drip irrigation, again, because there's no glue, it's very low pressure, some of the drip irrigation operates around 30, 35 PSI. Some operate much, much lower, even down to around 8 PSI. So that regulator reduces the flow, reduces the pressure so that you don't end up blowing your sprinklers, your drip pieces apart, your ends off, your emitters off. And so pressure regulation is very, very important. In addition to filtration, and I mentioned in our area, we've got pressurized irrigation that's not treated. It's actually just diverted water out of a river. It goes into some reservoirs. Some settling of debris happens, but there's still organic matter and sometimes small critters in that water that can pass through small half-inch, quarter-inch screens at the source in those reservoirs. So it's really important in our area that filters are used. If you're using a potable or culinary drinking water setup, the filters are actually still important, because if something happens to a line, it gets a little debris in there from a break, a cut with a shovel or something, that filter will prevent dirt from getting into emitters and plugging up emitters. And then you usually don't know those emitters are plugged until you start seeing plants wilt and stress and struggles that way. So most of the time in drip setups, you're going to use a pressure regulator and filter all together. They're built into one device, but they are sold separately as well. Drip typical screen minimum, you probably want to use 150. Now that number, the screen size is an indication of how large the openings are, the screen mesh is. The larger the number, the finer the screen, the lower the number, the more coarse the screen. And so 150 to 200 is probably adequate for your normal drip irrigation setup. If you've got it really, really fine and a dirtier source of water, you'll be cleaning that filter very, very frequently, which can be kind of a nightmare. Pressure regulation, I just on this screen just wanted to show you some of the pictures of different devices and what they look like. They'll actually say what they are on the side of them. You know, the Rainbird ones there with the colored L30, L30, L4, or M30, M40. That's 30 PSI, 40 PSI. Some of the others actually just label them 10 PSI, 8 PSI, 40 PSI, whatever the case is. So it's really easy to identify those pressure regulators and what they'll do for you. Here's a hose end connection that I talked about. If you're going right off of a hose bib, then the setup is very similar. You don't have a valve manifold, but you use a pressure regulator, a filter, and then the connections to the poly pipe. And all of these pieces are very readily available, very easy to assemble by hand. You don't need even a lot of tools. Most of the time they're hand tightened. And so they go together very, very well and very simply. And then you could run this irrigation zone from the hose, say to a vegetable garden, to some raised beds, even to a perennial type area. If those are the only sources of connection, you don't actually have a timer, you don't have a valve manifold and so forth. You can buy, as I mentioned, you can, on this slide, you can buy battery operated valves that can attach to hose where you leave that hose spigot, the hose bib open, and then that little battery operated valve will open and close as you need based on the timing you can set on those battery operated valves. Now, here was another video, but I think for the sake of time and for what it actually showed, I'm going to skip over this and then I'll just show you some of this when I get there. It was just the quick setup of a drip manifold, just the parts. And it's just what I described. You have a manifold, a valve, you can easily screw the pieces together. So I think I'll just skip over that one for now. Let's talk about pipe types. This is where we're going to get into the actual details of setting up sprinkler or setting up drip irrigation. Now, PVC is polyvinyl chloride. It's just plastic. Schedule 40 is what's used in our climate. If you're in warmer climates, Texas and California, you may have a Schedule 20 or something like that. The reason Schedule 40 here is it's much thicker. It tolerates the freezing that we have in our climate. But PVC is used primarily for main lines, where poly, once you get into actual drip applications where you're setting up the drip zones themselves, it's all a polymer type pipe. So it's flexible, it's bendable, it can be moved into different places, it's very easy to work with. But your main lines coming in are often, again, PVC, and to direct to the valves themselves, irrigation valves. And then from there, it's poly. Now, sometimes the main lines are also poly, but for the sake of the drip, now your poly lines, once you're setting up drip zones, are typically 1/2 inch in size or 3/4 inch in size. Rarely would you have anything larger than that for a drip zone. It's just not necessary, going back to the flow. You don't need that much flow typically, so it's not necessary to spend the extra money for a larger pipe. Lateral lines are the lines from your valve assembly to the delivery. So your main lateral lines typically sometimes there's no emitters, there's no anything, it's just taking water to where you need it, and then from there you have your actual, you have your secondary lines basically that are delivering water to each individual plant or to an entire setup as I'm going to describe in a second. So your main line provides water to the valve assembly, as I just said. So here in this image, there's a couple different types. I'm going to show you and explain each of those types. So drip irrigation always allows water to flow slowly to the root systems of the plants. That's a benefit for sandy soils or clay soils. Very little water is wasted. Again, helps with weed control, easy to install, easy to change. Also easy to chop through with a shovel if you've buried it and you don't know where it is. We've done that a lot. It's easy to fix, but it's also kind of a pain when you go chopping up your drip irrigation with a shovel when you're digging or weeding. Here's a couple little teeny repeat video things. There's inline drip. Notice that the emitter is built inside the pipe. Water looks like it's coming out of that little hole. And then point source drip, where water is coming out of the end. And in this case, that's just a bug cap with a little stake to keep it in place. So I'll talk about the emitters and how they work. But inline drip versus point source drip is a couple different methods we'll talk about and show you. Inline drip is best in this situation, like a picture you see here, where you'd have heavily planted areas. The density of planting material would require many emitters. It'd be a little bit tedious to set all that up. And also directing those emitters to every little plant, it could just add up in costs, everything else. So inline drip is good for that, where the lines are actually laid out. I'm going to skip to this slide. They're laid out in a grid-like pattern. And the grid-like pattern can curve if your beds are curved. But the idea is there's an emitter every 12 inches or 18 inches. And so your lines are spaced every 12 to 18 inches. They could be spaced closer together if the soils are very loose. But they're put into a parallel grid type pattern. This allows that water to basically be applied to the entire area evenly. Notice the picture on the bottom left. That's what you would expect from inline drip emitters. So that whole area is getting water, not every little space, although depending on soils, how you run it, the length of time you run it, that whole area could be soaked and even the surface wet. So it works quite well. It also works in the case of sparse plantings where in the case of this picture, a little loop is made around a shrub or a tree, and then one line is directed over to the next one with another loop made and so forth, where those inline emitters are in there. So on this particular shrub, there would maybe be 3 or 4 emitters because of the size of that loop, directing water to that one shrub. So point source drip, it is similar to what it's described. You're directing water to a specific point. And that is done through your distribution tubing, which is a 1/2 inch or 3/4 inch, followed by 1/4 inch, what's referred to often as spaghetti tubing, being attached with barbed fittings or emitters punched directly into that distribution tubing, and then that directs water to that specific point. So there's no other emitters in the pipe. You're placing those emitters where they need to be and directing the flow to the specific point. And so this is a good approach for maximum weed control when your plantings are a little less sparse or a little less dense, more sparse planting. And then you also can control volume because you're dictating the size of emitter. You could have a 1 gallon emitter, a 2 gallon emitter, 3, so forth. And these are per hour volumes. And so if you needed a plant, you have a plant that needs a bit more water at a given time, you could actually increase the flow to that one plant by installing a larger emitter size. So the little picture at the top kind of shows you the different options of where to place emitters. Emitters right on the pipe with spaghetti tubing coming off of them, an emitter directly on the pipe only, or an emitter at the end of the spaghetti tubing right at the point where you want water delivered. So here's a couple pictures that show maybe a sparse planting where point source drip irrigation works quite effectively. Notice you can't see the distribution tubing. It can be buried, it can be hidden under mulch. That's actually the way I prefer to do it, is not to bury it too deep, but to hide under to where if you need to access it, you can easily just scrape back mulch, you find your pipes, and you can repair or dig or do what you need to do without chopping into your pipes. So now again, I'm going to show you these. I'm going to switch gears here in a second, but I wanted to cover some of the real basics with some slides. So let's talk about the retrofitting. Many people have existing spray irrigation and they want to be able to convert over to drip, but it seems very daunting. It seems like you have to do a lot of digging, replace pipes, and so forth. In order to convert, if you can at least convert a whole irrigation zone, every spray head in that zone, the conversion is very easy. So new technology, a couple pictures here show little conversion kits where you can convert from a spray head and then attach drip tubing to that spray head or drip emitters and different things right to that head. And you're either capping off the other heads or you're converting every one of those heads to connect to that poly pipe in that one zone to direct water and now put it to drip. So that's these technologies, the kits, the products that are being made available are becoming more and more accessible, easy to use, easy to find, and make it very easy to convert spray zones to drip zones. Even with inside these, there's a pressure regulator and a filter right inside, and I will show you that here in a second. Here's another slide with that, again showing some of the tools, some of the products that you can go directly from spray to drip. Very important though to do the whole zone because of the volumes. You can't mix spray irrigation with drip irrigation because there's too high a flow for spray compared to the low flow for drip, and either you'll drown something or you'll dry it out. So one other product I want to talk about briefly is drip tape, sometimes referred to as trickle tape or T-tape. Now this is actually something that's being used in more agriculture row crop settings. I've used it in my own garden at home. I've seen people use it in raised beds. We had a little demonstration here in our own garden at work where we're using it in raised beds, and it works really, really well. It was developed for agriculture purposes. It was actually developed in Israel and then has been refined, and many companies sell a product similar in different names, but it was designed for low water application, but very effective row crop application because it will deliver water the entire length of the row at an equal distribution. Unlike soaker hoses or different things where one end is always flooded and the other end is dry. So here on the left, it shows some of the different size tubing. It's a flat, very, very thin type flat tubing. It's when it's pressurized, when water goes in, it actually fills that up and turns it into a round tube, a round pipe. And the different sizes are different millimeters thick. And then it has special little channels that it flows water through to deliver water effectively and evenly down rows that can be even 100 feet long, a couple hundred feet long. Very effective irrigation. And then in the middle, I showed a bunch of the fittings. Super easy fittings. The tubing slides onto those barb ends with a little twist of a fitting there, and it locks it into place. This stuff is operated on very low pressure. This is where you're talking to 10 to 12 psi, depending that and so forth years, and I've loved it. My gardens thrive. I'm not watering everything. Of course, it runs for a longer period of time. I'll run this for anywhere from, depending on the time of year, 60 to 90 minutes is what's typical for my own garden. And then I'm able to spread that out because it soaks the air really well, and I spread that out every few days. So here's a picture of how those might be set up in some raised beds, a regular field, just a little section there of a garden that's been tilled up. So this is a good method if you're doing something more in straight rows. This could be used in a landscape setting, but it is actually kind of designed to be disposable. You wouldn't expect the length of the duration or the longevity of this type of pipe because it's relatively inexpensive per linear foot. And for agriculture setting, oftentimes they don't reuse it. They'll use it for 1 year, they'll dispose it, and they'll run new lines the following year. It can be buried shallowly or hidden under mulch to keep it out of the sun. The sun is what really works on some of the stuff and can make it brittle over the course of a season or two. So drip tape, I've already kind of talked about these things, but it's set up with a poly tube header and then punched in with little barbed fittings that then connect to the tape. Can be connected to a hose faucet, a hose bib, like it shows right in the other picture. And so with that, I've got a couple resources. I think Candace will make this presentation available. So there's lots of drip stuff online. Every manufacturer of Rainbird, Orbit, Hunter, Toro, all those main manufacturers are doing drip. There's special companies, DripWorks, Drip Depot, and CWEL. I've put a little link to CWEL, USU Extension, as a publication on irrigation. So anyway, those were some quick slides. I'm just going to exit out of here now, and I'm going to share. Hold on here just a second. Actually, I'm going to do this. Oops. What did I do here? Here we go. All right, so now you should be able to see me, I hope. So with this then, now let's go through some of the pieces here. I'll start out with the valves and pressure regulation. So here was kind of that typical setup where this is a commercial valve. So residential valves will be very similar to this. This one actually has a little flow control knob, right here on top. Here's where you connect to your timer. But so inside this canister, this is where you'd have your filter. Pretty typical filter. Nothing special about this. I think this is a 200 mesh. Notice on the side of this, that's where it says 40 PSI. So we, in our garden out here and at home, because this is more of a commercial setup, I haven't used anything like this at home because I have another filter. My setup at home is more like this, where this is the pressure regulator. It says 30 there on the side, and then just a smaller filter for each zone. Inside, here's your filter. So this is something that works really well. But every time you do drip, again, it's recommended that you just have a filter, because anything in the main line leading up to your sprinkler, leading up to this valve or this zone of irrigation, if there's debris in there, you don't want that debris getting stuck in the emitters of the pipe, into your emitters and tubing. So filtering that, if something gets cut afterwards, well, usually at the end of a poly line, and I'll just show you one of these here. Usually at the end of, this is a typical 3/4 inch poly for drip. So at the end, they would have a little end cap that you're able to flush these pipes occasionally. And it's actually recommended that every year probably that you just open up the end cap, you let water flow through, and it flushes any debris that's actually in this main pipe. It's able to flush that out so that it's not getting stuck in the smaller tubing or the emitters. So, all right, with that, let me move to the inline. The inline, and Sorry, I keep diving out of the screen here. So the types of tubing. So I'm going to show you here. This is a 1/2-inch tubing. This is the inline tubing, and I'll put it a little bit closer. That's the emitter. Notice there's just a little bump in the tubing. This one happens to be brown. There's many manufacturers of this. Rainbird has one. There's a brand called Netafim. Some people, it's kind of like that Band-Aid thing. Band-Aid's a brand, but sometimes when you need a bandage, you just say, I need a Band-Aid. Well, a lot of this type of inline tubing, it seems that some people just simply refer to it as Netafim, but Netafim is a brand. But this stuff works quite well. Let me show you. I've cut a little cross section here. So there's the emitter. And so that cutting this open, it's just a special little device in there that allows water to move through some very small channels. So it's pressure compensating, meaning that every emitter puts out the same volume as it goes through the system. So I've got another one here, completely cut open. Let's see, here we go. That's what it looks like on the back side. There's the emitter opening, and that's what the whole little emitter inside the tubing looks like. And that just regulates flow. It's pressure compensating, so every single one of these holes puts out the same volume. Typical volume output on inline tubing is anywhere from 0.6 to 0.9 gallons per hour. So we usually just round. If it's 0.9, you're about at 1 gallon per hour, and that's how you usually determine how long you're going to run the system. You kind of figure, okay, I've got this much area, 1 gallon per hour, here's my soil type, I need to run that zone for an hour, or I need to run that zone for 70 minutes, 80 minutes, whatever the time is, to get 1 gallon per hour per emitter in that zone. All right, so then point source. Now I've got this drip tube here that has 3 or 4 things on it, but I'll show you each one of these as we go. So the point source tubing, as I showed you in the slides, here's your typical 3/4 poly. 1/2-inch poly is the same. It's a thin wall. It's just a smaller diameter. But here's an example where an emitter is punched directly into the side of the pipe. Otherwise, you would be using a little barb fitting. So this little barb fitting is punched in with a 1/4-inch tubing connected to the barb, and then the 1/4-inch tubing leading out here to an emitter on the end. So then that emitter is what's controlling flow. So if you want the emitter just directly in the pipe, let's say your pipe is running right next to a plant here, that's an easy way to do it, just punch right in. But if you need to direct water out, then, I'll kind of zoom back here. You can direct water, you can direct these tubes, you can run spaghetti tubing. I think the maximum length they say is 22 feet. I would never do that. When people ask me, I'd say never go more than 10, just because if you're going more than 10, you probably just need to loop your main line around the other side of the bed so you don't have to direct spaghetti tubing all over the place to get to your plants that you need. Because this is flexible, so again, you don't just have to have one line. You could have two poly lines. They have tees. You can tee it and loop it. It can be looped together on itself. It can connect together, and it's easy to just direct water exactly where you need it with those drip emitters. The 1/4-inch spaghetti tubing is what's used to connect to the emitters. So you have poly, what we call spaghetti tubing. It's also a poly type tube, very thin, very easy to work with. So now let's talk about the emitters. So I got one, I had this little piece here that showed, here's a barbed end that would punch into the main line, the distribution tubing. Here's a setup where it has a little stake. Every manufacturer sells their own little stake to keep it in its location. You don't have to use those. And then the emitter on the end. So with that, let's talk about emitters here for a minute. I'll try to show you these. Most manufacturers, they color code their emitters. So this particular one I'm holding is a Rainbird emitter, and it's 2 gallons per hour. You probably can't see this. No, it's going to be blurry. On the very end, oh, maybe right there. No, anyway, on the very end of the emitters, they say a little number. They'll have a 2 GPH, gallons per hour. This one's also Rainbird. This one's black. This is 1 gallon per hour. They have a blue one that's a 1/2 gallon per hour. And then as they go up, they're color coded. Every manufacturer has one. This one's not a Rainbird, I don't believe. Anyway, they're color coded. So this one's green. This one's actually 15 gallons per hour. So you can direct, like I mentioned, you can direct volume and flow to plants. You've got trees in a zone with some power, but you want a tree to get 5 or 10 gallons per hour. Well, you can control that by the emitter, or you can simply put multiple emitters to the base of that tree around its tree line, the drip zone. And then, if you're using 4 2-gallon per hour emitters, now you're getting at least 8 gallons in that tree, in that drip zone of that tree, depending on the size of the tree. Another type of emitter, they call them flag emitters. And it's just because it looks like it has a little flag on the end. And same thing. One nice thing about flag emitters, though, is they can actually be taken apart. You can take that little piece apart. So this is the little flag in the end. And you take that apart. Sometimes a little bit of debris, if it gets in there, you pull that apart, it can flush water through, and then you can put the flag back in. So these are kind of emitters that are able to be cleaned just a bit. It doesn't matter which direction that flag is usually. In this case, same thing. They have different volumes. You can have 1 gallon to 5 or whatever gallon per minute, or excuse me, gallon per hour type flows out of these emitters. So emitters are a good way to go to direct the volume you need to specific plant needs. Now, remembering when you're doing all of this, you've got to remember that if you put a 2-gallon per hour emitter, or let's use a 5. If you put a 5-gallon emitter with 1 gallon per hour emitters, you still need to realize you're running the zone for as long as it takes for the plant that needs the most. So if you have plants that have a 1 gallon emitter and you need a full hour, you got to remember, just because you put a 5 on there, it doesn't mean you're running it less. It's going to run for a full hour and you're going to have 5 gallons there. So it's always important to think about the total volume you need and the total time you need, and then you can start mixing and matching emitters. In most cases, for myself, I like to use the same volume emitter, and if I have a plant that needs more, I just apply 1 or 2 or 3 or whatever that number is. And in many cases, if you've got enough plants around trees, because tree roots go everywhere, those tree roots are also benefiting from the water you're applying with your other plants in a perennial bed or shrub bed or something of that case. So sometimes you don't need as much extra water around a tree as you think. So with that, while I've got this in my hand, I'll show you the way the drip tape is set up. So here's one of those fittings. It's super easy to undo. It just screws off. And then this drip tape can slide right off of that barb. So here's where it looks round here, but this drip tape is actually flat. On the back side of this is the little channels. That's a little area where water comes out right there. And anyway, this comes in different thicknesses, different sizes, but it's super easy. You kind of just open that up a little bit. You can push it right onto a barbed end, and then that just twists. It just twists right around, and it holds it fast. And then there's another fitting just like this one that would go on the end. Or if you're a cheapskate like I am sometimes, you invent your own way where you can just fold. You can actually fold this material over on itself a couple times, cut just a tiny little section of it, and slide it over the end on the end side, and that'll actually keep water from running out. It may drip just a little bit because it doesn't seal it 100% tight, so you get a little bit of dripping out of that end. But to avoid the cost of extra fittings, if that's an issue, you can do it that way as well. So I'll put that down. All right, so I did forget to mention on the inline pipe, this is what the barbs look like. So your inline drip tubing, the little barbs are just push-on barbs. They just fit together. They're actually quite tight. So I'm not able to push that in just doing this kind of thing with my fingertips. You'd have to give it some force. Sometimes people actually like to leave this tubing sitting in the sun for a little bit, makes it a little bit warm, a little bit more flexible, and then they can easily push those these little barb fittings on. Those do not need clamps. They don't need glue. Once they're on there, you cannot pull those off. High enough water pressure may be able to pop that off, but usually you just don't get those off. To get them off, you have to kind of cut them, carefully slice through that without damaging your barb to get that piece of tubing off of there. All right, so the last little bit here on conversion. So converting from drip to spray, I wanted just to show you this. So typical spray head, You know, assume you've got a head like this and it's got just your regular spray nozzle. That's what this body is. It's a spray body. So if you were to take the guts out of the spray head, basically as a little spring in there, you just pop all that out, now it's empty. So that's what's been developed, is you have an empty canister, and now what they do is they have a little filter connected to a pressure regulator right on attached to a lid, basically a spray body lid. The whole thing slides in and screws on, and now you've converted that spray head to a drip connection. And then because of this end, it's got 6 little ends on here, you can connect spaghetti tubing right to it and then direct water to where you need from that. If you don't want to use this and would just rather connect to the poly pipe, I did show in the slides that image. There's just that special little fitting that basically takes a barbed fitting with a threaded end, and you're able just to put that barb right on there and then now connect tubing, your actual distribution tubing, inline or point source, right to this. Pressure regulation happens right here, little filtration happens right here, and then either you just connect to one point, and then with all your other heads in that zone, you've capped them, or taken them, take them out, cap them off. They actually sell just special little caps here, so you can just cap them right at the top. Or you tie the same kind of connection in with it like this. You could convert every head in the zone, and now you have enough spaghetti tubing and emitters to go to all your plants. Or you run your tubing and so forth. So that's one way. The other way is assuming that you have a riser, typical riser that's coming off of this is just a barb fitting, but say that was a PVC pipe. You have your riser and then a sprinkler head connected to that riser. You can undo the sprinkler head from the riser, and then they have devices like this. Looks a little bit science fiction, maybe spaceship-like. It can thread right onto that riser. And then inside, this is a pressure regulator. And then inside here, there's a small filter. And then right here is where you have, these are little plugs, or you have an opening for your drip emitters right there. Or you leave these completely open and you connect tubing to that and place your emitter on the end of the tubing with a stake. And so emitters can go right inside, or emitters can go on the end. Either way, it works very well. Same concept as before, though. You just converted a spray head to a drip. This can be at ground level here. This can be kind of flat at ground level or hidden under mulch, so you don't actually see it. But these would go barely down under the ground and then kind of back up. So, but this is just a couple of ways to convert from spray to drip. So I did also have here one demonstration of a battery operated valve. So assuming you're adding a drip zone, you're trying to do something, but you can't run wire all the way back to a timer in a shed or garage or something, as long as you've got a main line bringing water to the sort to where you need it, you could install a valve like this. That end actually connects right to this little unit here, which is programmable, and it just runs on a 9-volt battery. So, that's one method. I said there's hose end timers. I have all these pieces, but for time, we're out of time. There's lots and lots of pieces to use, lots of things to be involved with, and it's easy. Once you start to get the hang of it, it can be overwhelming because you can have so many products. If you look online, there's a million things out there. Don't get overwhelmed. Everybody can do this, and your expertise will grow as you start experiencing and using drip irrigation. So I think with that, I'll wrap up, and then let's talk about some questions.
Amazing. This is recorded as always, and will be up on the Center for Water Efficient Landscaping's YouTube page, hopefully within the next couple of weeks.
All right.
All right. Thanks, guys. We'll see you next month.
All right. Bye.
Bye.